Sonic, the heart of your system.
Hi and welcome to my RTX 2080 overclocking video. As you can see next to me, I already have assembled a setup with RTX 2080 non-TI in this case, and in today's video we will try to overclock this card first on air and later we will move over to dry ice. I ordered 30 kilograms of dry ice, which hopefully will give us a little bit more headroom in temperature and therefore we will be able to clock the GPU higher. First of all, I ran some baseline scores, so I ran the superposition benchmark, which you can see on the screen. The baseline score is 8,960 points. The setup itself is a Maximus 10 Apex with an 8600K, which is clocked currently to 4.8 GHz. It's not really limiting the card because we will just run 4K benchmarks today just to see how the clock itself of the card affects the graphics performance, and we will not really touch the CPU. We have 16 GB of memory on there, Corsair sticks with 3466 MHz, and the whole setup is powered by a Seasonic 1200 watt PSU. In the first step we will just do some basic testing and see how high we can push the GPU with software. So for example, if you use GPU Tweak 2 from Asus or MSI Afterburner EVGA Precision X, all those tools are very similar, and we will see how high we can push the GPU just by unlocking the power limit in software, see what happens if we push the fan to 100%, how high we can clock the card, just to get some baseline numbers. Afterwards we will disassemble the card, we will do power mod modifications. This time we will solder the power mod instead of using liquid metal, because previously we had some issues. After let's say a year or two, I heard or got some feedback from people that the gallium inside the liquid metal dissolved some of the solder of the shunt resistors, and therefore shunt resistors fell off. So that's why today we will try to do a little bridge over the shunt resistor and therefore unlock the power limit this way. Afterwards we will also try to do a voltage modification. We cannot access the voltage over software, so we will have to do some hardware modifications. If everything works out, we will be able to connect the Elmore EVC again, which you know from my previous videos is an I2C device, and then we can easily access the voltage over a laptop, over an external device, and this way adjust the GPU voltage. So yeah, I will just move the camera closer, then we will do some baseline testing, see how high we can push the GPU on stock, and then we will see how it goes with dice. Okay, as you can see, a lot of things changed. It's actually one day further now, and yeah, we decided to just go through it all, and I recorded everything, so I will just talk over it and show you the footage. So the basic and first testing we did was just running the the card in the system stock, and we recorded a frequency of 1860 MHz during superposition benchmark, and the current drawn over the 6-pin and 8-pin connector in that time was about 15 amp. Then we increased the power target by plus 20%, did the same testing again, and the card was clocking at around 1905 MHz, while it was drawing 17 amp through the 6-pin and 8-pin connector. So that gives us some kind of basic numbers, so we know what to expect. In the next step we increased the fan speed to 100%, but we saw that there was no increase in clock speed, so it was still 1905 MHz on the GPU. Then we increased the power target by plus 20% and did 100% fan speed, and then we saw that the clocks increased to 1935 MHz on the GPU, while the power consumption also increased a little bit at around 18 amps across 6-pin and 8-pin together. Then we moved over to manual overclocking, so plus 150 MHz on the GPU, which results in 2070 MHz total during superposition benchmark, while keeping plus 20% power target and also the fan speed at 100%. We also tested to push the memory to the maximum, so it was 16,000 MHz on the memory. We first tried plus 170 MHz on the GPU, but when we did that, the GPU was running so hard on the limit that we could not overclock the memory anymore. So that's why we had to go back to plus 150 on the GPU, and then we could increase the memory, and actually memory overclocking helps a lot on those cards. So we saw an increase from plus 7% to plus 12% just by increasing the memory speed. And I also did an additional test where I just overclocked the memory and not the GPU. And the funny part is that the power consumption of the card itself at stock stays at the target, but you get a performance increase of about 5 to 6% by just increasing memory speed. So if you're overclocking the card, or if you plan to overclock the card, do not forget to touch the memory. After the baseline testing, I removed the backplate, so just removed the first screws and then removed the second layer of screws to remove the card itself from the cooler. Cleaned the card because there's a lot of thermal paste on there actually, and the thermal paste is not even that bad performance wise, because even after I repasted it afterwards, the temperature difference was not big, so I can say that the stock thermal paste on the 2080 should be fairly okay. So the first step in tuning the card is applying the power mod. And from my previous videos that I always used conductor nodes or liquid metal across the shunt resistors to improve the power reading or fool the power reading, and therefore do a power mod. We need the power mod because otherwise, if we increase voltage, if we increase clocks, the card would lose the clocks over time, it would clock down. And we want to have the card stable at the same clock, at the same voltage all the time. That's why we have to do the power mod. And the power mod area is on the bottom right region of the card. You can see 3 shunt resistors. One is for the PCI Express slot, one is for the 6-pin connector, and one is for the 8-pin connector. And the card itself is able of doing power shifting, so it can record the power drawn from the PCI Express slot, from the 6-pin connector, and from the 8-pin connector. And if it detects that the power drawn from, for example, the PCI Express slot is too high, it will shift over more to, let's say, 6-pin or 8-pin. That's why we will also only mod the shunt resistors of the 6-pin and 8-pin connectors, because we want to stay within specs of the PCI Express slot. So this time we decided to solder across the shunt resistors, which I'm not really a fan of. It's not because it's a permanent mod, it's more like because if the resistance across the shunt resistor is too low, then the card is going into the error state, and that's also what happened to us. So after modding the shunt resistor of 6-pin and 8-pin connectors, we assembled the card again, went into Windows, ran superposition benchmark, and we saw that the card was always running at 300 megahertz no matter what you do. And this is exactly what happens if the resistance is too low across the shunt resistor. And that's what I always try to tell people. That was the reason why I mainly used liquid metal back then, because the resistance is low enough to improve the power reading, but not low enough to run into the error state. So what we had to do is we just cut the wire across the 6-pin connector, so we only basically modded the 8-pin shunt resistor, and then it was fine. After power modding, the card was always running at 2100 megahertz, always at 100% fan speed. What's also interesting is that the GPU voltage will always stay at 1.05 volt, while typically stock is 0.98 volt, and without the power mod, the maximum you can get is typically 1.04 volt. The negative part obviously is power consumption. So the power drawn across 6-pin and 8-pin together was 20.2 amps, while considering stock is 15 amps and overclocking manually just by software 17 amps, the power mod really drastically increased power consumption. While you only get 20 or 30 megahertz more, it's really not worth it. The goal of our testing is to use dry ice, so that's why we will use this container that's called the Raptor 4. That's something I can just mount to any GPU, then we can fill in either liquid nitrogen or dry ice and therefore cool down the card to whatever temperature we need. And in today's video, we will also wanted to test if it's worth to use a water block. So we decided to mount this cooler on the card, or that's what we wanted to do, and to go down to like plus 20 degrees Celsius on the GPU, because in this way we can simulate a very strong water cooling block, let's say with a chiller, and see if it's really worth to go that far. But before we can do that, we need voltage control. So we decided to go with the Elmore EVC again. So it's an I2C device we can solder with 2 pins to the card. So we have SDA and SCL, 2 points that can be found on the card. You can see a picture now where to access them. And with this I2C device, with the Elmore EVC, we can easily access the voltage controller of the card and just control the card itself over an external device. So we have a laptop standing next to it. And with the laptop and the EVC software, we can directly access and control the GPU voltage. The soldering points for the I2C are really, really small. So this is more like really advanced overclocking. And I also use this USB microscope here, which you know from my die shot videos. So this is really helpful if you want to do close-ups and double check soldering joints. A USB microscope like this can be really helpful. Actually, first, before we did the right mod, we kind of messed it up. We had the wrong data sheet, and then we scratched the wrong points, did the wrong soldering, or soldered to the wrong points, tried it, it didn't work, and then we figured out that we had the wrong data sheet. So I think we wasted like 2 or 3 hours just on that. But eventually we had the correct data sheet soldered to the correct points. Those are the points I showed you earlier in the video. And then we connected the EVC, connected the laptop, and everything worked out. There's something else we needed. We call it the NVIDIA unlock device, and it's nothing else than a tweezer. And we needed this tweezer to put it in the connector of the EVC to short SDA and SCL pins of the card. The reason for that is that during initialization of the card, during boot, the BIOS of the card will lock the voltage controller. And if we short SDA and SCL, there is some mix-up during the signaling, so it will just read some crap, and then the BIOS cannot lock the voltage controller anymore, and this way we will have full access in Windows. So after we confirmed that voltage control was working, we mounted the card on the GPU pod. And of course we use a lot of thermal paste. Don't be fooled by that, because typically people will say, hey, why do you apply so much thermal paste? It's really not needed. You need a very thin layer. But for any kind of extreme overclocking, we figured out we really need a lot of thermal paste, because it will cover the edge of the chip and will also dissipate some additional heat through the edge, and we will get a better performance. We did a lot of testing around that, and we really need a lot of thermal paste. In addition, we added some paper towel to the card just to protect it from any kind of condensation. Our testing was planned to be just like 30 minutes, maximum 45. During this time we will not have that much condensation, so we didn't really want to ruin the card with either Vaseline or Plastidip, so that's why we just went for straight paper towel insulation. Also added a little bit of paper towel to the board itself. Once everything was ready, we went down to about plus 20 degrees Celsius on the container, as I said before, because we wanted to simulate proper water cooling and to see if it's really worth it. And we figured out it's not, because you can still push the GPU to 2100 MHz, which is exactly what we could do before. The only thing I noticed is that the power consumption is quite a lot lower. So it went from like 18.5 amps to around 17 amps. So you can say that you're saving, depending on which condition, which situation, probably 20 to 30 watt during load by applying a water block, but you will not be able to clock the card higher just by putting a water block on it. The temperature difference is not enough for this on Turing. That's actually the same as what we saw with NVIDIA Pascal. So 1080 Ti, for example, we did exactly the same testing, and we also saw that the temperature scaling and voltage scaling is not really there. So we also did testing with additional voltage and let's say plus 20 degrees Celsius, so simulating the water block situation, and even there we could not push the GPU higher. So there is no voltage scaling. So if you're planning to overclock your card, of course you can apply a water block. You will be able to clock a bit higher because the card will simply stay colder. You will not reach the temperature target that early, but don't expect too much. Like 100 megahertz maximum from stock is what you can expect by moving from stock cooler to a water block. Then we went full out, so we filled the GPU container completely with the dry ice nuggets and also added some 3-Novec for heat transfer. Typically we also add like acetone or isopropanol. You can just take whatever alcohol you want, which has a very low melting point, but 3-Novec in addition is not electrically conductive, so if we spill something, it's more safe and it also doesn't smell as bad as acetone. So that's why we went for 3-Novec this time. Then we went down in temperature. Pod temperature, the lowest we could achieve was minus 72 degrees Celsius. And we also noticed that we can read negative temperatures in GPU tweak, which is very unusual. Typically, all those temperature sensors, they stop to work at 0 degrees Celsius or they just read out something really weird. But even at GPU tweak, it would not show lower than minus 40, so that's the lowest we could read there. That's why we always have to rely on the temperature probe, which is fixed on the GPU container. So with stock voltage, we could run 2295 megahertz on the GPU, and that shows how much it scales by just lowering the temperature a lot. So minus 70 degrees roughly on the GPU will be able to clock the card to 2300. Then we increased the GPU voltage to almost 1.2 volt, and the maximum we could push the GPU clock to was 2340 megahertz. So again, we can see that there is some voltage scaling if we're really running on the edge at really cold temperatures, but the scaling is almost not there. So 2300 to 2340, yeah, it's not really worth it. So voltage modding on Turing cards is absolutely not recommended, but still is a really nice result. So 2340 megahertz on the GPU, 16,000 megahertz on the memory. We were able to push the performance in the end by plus 20%, increase the performance by 20%. But the power consumption increased by 50%. So this shows that at stock, the cards are running pretty much at a perfect efficiency. So whatever you do, if you increase the power target, if you increase the voltage, you will only get a small performance gain, but the power consumption will really increase by a lot. So plus 50% power consumption while increasing performance by plus 20%, not really worth it. So final score in superposition benchmark was 10,700 points, which is really solid for a single GPU. Of course, 2080 Ti would score higher, but I'm pretty sure that it would scale or react exactly the same. So it's just a bigger die, it's the same architecture, the same manufacturing process. So you can expect the same kind of temperature or voltage behavior from a 2080 Ti. So as I said before, the conclusion would be, of course, if you want to plan to do massive overclocking, you need like very solid temperatures. And we're talking about dry ice overclocking or liquid nitrogen. If you want to do daily overclocking, of course, you can go for a water block. It will help you to run the GPU a little bit colder. It will lower the power consumption, but don't expect that you can clock your card suddenly 100 or 200 megahertz higher because you moved from a block like a very solid air cooler like the Founders Edition to a full cover water block. It will not help you that much. So that's it for today's video. I hope you enjoyed the insights you got from 2080 Ti or 2080 overclocking. If you have any kind of questions about this, put it please down in the comments below. See you soon.